Neptune's cosmic dance partner, the solar system's strangest orbit revealed. A groundbreaking discovery in our solar system. Astronomers have made an exciting discovery that could change our understanding of the solar system, a unique trans-Neptunian object named 2020 VN40. This celestial body is unlike any other known object, as it moves in a synchronized rhythm with Neptune, offering new insights into the dynamics of the outer regions of our solar system. A fascinating orbital relationship. 2020 VN40 is the first object identified that completes one orbit around the Sun for every 10 orbits that Neptune makes, establishing a 1:10 orbital resonance. Such resonances occur when two celestial bodies exert gravitational influence on each other, even across vast distances. This unusual orbital behavior indicates that Neptune's gravitational influence may extend much further than scientists previously believed. While many trans-Neptunian objects, TNOs, share similar resonances with Neptune, they typically reach their closest point to the Sun, known as perihelion, when Neptune is positioned on the opposite side of the solar system. However, 2020 VN40 defies this conventional pattern. From a vantage point above the solar system, it seems to approach the Sun when Neptune is nearby. In reality, the two bodies are never in close proximity, as 2020 VN40's orbit is significantly tilted compared to the flat plane of the solar system. Investigating the outer reaches. This remarkable discovery is part of the Large Inclination Distant Objects (LIDO) survey, a project dedicated to studying objects with highly tilted orbits in the outer solar system. Utilizing data from the Canada-France-Hawaii telescope, along with follow-up observations from the Gemini Observatory and Magellan-Botta telescope, the LIDO team has been diligently scanning the sky for elusive celestial bodies in these distant, unexplored regions. 2020 VN40 travels along an orbit that is approximately 140 times farther from the Sun than Earth, on average. Its steeply inclined orbit sets it apart from many other known TNOs, which generally follow flatter trajectories. Challenging existing theories. The peculiar behavior of 2020 VN40 raises questions about current assumptions regarding orbital dynamics within our solar system. Most known objects that resonate with Neptune adhere to patterns that prevent them from aligning closely with the planet when they are near the Sun. However, the alignment of 2020 VN40 suggests a different type of motion that has not been recognized in previous solar system studies. This discovery opens the door to the possibility that there are many more objects with similarly unique orbits yet to be found. These resonant and inclined orbits could provide valuable insights into how celestial objects migrate and evolve over time. They may represent remnants of a more chaotic early phase of the solar system, a time when planets were still in motion and scattering smaller bodies throughout the cosmos. Looking ahead to future discoveries. To date, the LIDO survey has identified over 140 distant objects, and astronomers anticipate that many more will be discovered in the future. With upcoming observations from facilities like the Vera C. Rubin Observatory, scientists are hopeful that they will uncover even more unusual trans-Neptunian objects and gain a deeper understanding of how their orbits have been shaped over time. What are your thoughts? This discovery not only expands our knowledge of the solar system but also raises intriguing questions about the nature of celestial dynamics. Do you think there are more objects like 2020 VN40 waiting to be discovered? How might these findings reshape our understanding of the solar system's history? Share your thoughts in the comments. Mystery of 2020 VN40, the solar system's dance with Neptune. Astronomers have made an intriguing discovery. A peculiar celestial body located at the far reaches of our solar system is engaged in a synchronized dance with Neptune. This unusual object, known as 2020 VN40, belongs to a category of distant solar system entities referred to as trans-Neptunian objects, TNOs. Remarkably, 2020 VN40 is the first known object that completes one orbit around the Sun for every 10 orbits that Neptune makes. Given that a single year on Neptune spans approximately 164.8 Earth years, this means that 2020 VN40 experiences an astonishingly lengthy year, lasting around 1,648 Earth years or 19,776 months. The research team believes that the unique orbital relationship between 2020 VN40 and Neptune may have originated when this object was temporarily captured by the gravitational pull of the ice giant. This finding could provide valuable insights into the dynamics of celestial bodies situated at the outer edges of our solar system. This is a significant advancement in our understanding of the outer solar system, stated Rosemary Pike, the team leader from the Center for Astrophysics at Harvard and Smithsonian. It demonstrates that even the most remote areas influenced by Neptune can harbor objects, offering us new clues about the evolution of our solar system. The rhythmic orbit of 2020 VN40 was identified through data collected by the Large Inclination Distant Objects (LIDO) survey. This survey employs the Canada-France-Hawaii telescope, with additional support from the Gemini Observatory and the Walter Baade telescope, to explore the outer solar system for unusual objects. LIDO specifically focuses on locating TNOs that have orbits that extend significantly above and below the plane of Earth's orbit around the Sun. These regions of the solar system have been relatively unexplored by astronomers until now. It has been captivating to discover how many small bodies exist in the solar system with such large and tilted orbits, remarked Samantha Lawler, a researcher from the University of Regina and a member of the LIDO team. The highly inclined trajectory of 2020 VN40 places it at an average distance from the Sun that is about 140 times greater than the distance between Earth and the Sun. However, the most fascinating aspect of 2020 VN40's orbit is its resonance with Neptune's orbit. Typically, other celestial bodies that are in sync with Neptune reach their closest point to the Sun, known as perihelion, when Neptune is at its farthest point from the Sun, or aphelion. In a surprising twist, 2020 VN40 reaches its perihelion when Neptune is also near the Sun. From a vantage point above the solar system, the tilt of 2020 VN40's orbit indicates that this TNO and Neptune are not actually close to one another. In fact, 2020 VN40 is situated far below the solar system's plane. This unique characteristic distinguishes 2020 VN40 from other resonant TNOs, which generally remain within the solar system's plane during their closest approaches to the Sun. This new motion is akin to discovering a hidden rhythm in a familiar song, commented Ruth Murray Clay, a scientist from the University of California, Santa Cruz. It has the potential to alter our understanding of how distant objects navigate through space. The peculiar orbital behavior of 2020 VN40 suggests that solar system objects with steeply tilted orbits can exhibit novel and unexpected movement patterns. The search is now underway for additional bodies similar to 2020 VN40, with the newly operational Vera C. Rubin Observatory poised to play a crucial role in this exploration. This is merely the beginning, stated Catherine Voke, a researcher at the Planetary Science Institute. We are opening a new window into the history of our solar system. The findings regarding 2020 VN40 were published on July 7 in the Planetary Science Journal. Join our space forums to continue the conversation about the latest missions, night sky events, and more. If you have any news tips, corrections, or comments, feel free to reach out to us at community@space.com. Robert Leah is a science journalist based in the UK, with articles featured in publications such as Physics World, New Scientist, Astronomy Magazine, All About Space, Newsweek, and ZME Science. He also writes about science communication for Elsevier and the European Journal of Physics. Rob holds a Bachelor of Science degree in Physics and Astronomy from the Open University in the UK. Follow him on Twitter at ScienceF1RST. Strange object orbiting Neptune, 2020 VN40's unique 10:1 resonance. Imagine this, a mysterious traveler is making its way through the outer edges of our solar system, and it's not your typical moon or asteroid. This peculiar object, named 2020 VN40, has astronomers buzzing with excitement, and for good reason. Discovered by the LIDO survey, a groundbreaking initiative led by the Center for Astrophysics at Harvard and Smithsonian, this icy wanderer isn't just floating aimlessly. Instead, it moves in a fascinating rhythm, completing one orbit around the Sun for every 10 orbits Neptune makes. And here's the kicker, this is the first time scientists have confirmed an object with such a unique orbital pattern. But why does this matter? Let's dive in. The discovery of 2020 VN40 sheds new light on how distant objects behave in the outer solar system, particularly under the gravitational influence of Neptune. It turns out that Neptune's gravity can temporarily capture these far-flung travelers as they pass by, influencing their paths in ways we're only beginning to understand. This finding was made possible thanks to the Canada-France-Hawaii telescope, with additional observations from the Gemini Observatory and the Magellan-Baade telescope. These global collaborations highlight how teamwork across continents can uncover secrets hidden at the edge of our cosmic neighborhood. Now, let's talk about the LIDO survey's mission, which is as ambitious as it is intriguing. The team set out to identify objects whose orbits soar high above and plunge far below Earth's orbital plane around the Sun. These high-flying bodies belong to a lesser-known region of the solar system, a cosmic frontier that remains largely uncharted. As Dr. Samantha Lawler from the University of Regina, a key member of the LIDO team, puts it, it's been fascinating to uncover just how many small bodies in the solar system exist on these incredibly large, highly tilted orbits. What makes 2020 VN40 so special? For starters, it's incredibly far away. On average, it's about 140 times farther from the Sun than Earth, traveling along a steeply inclined path through the solar system. Even more curious is how it interacts with Neptune. Most objects that share a synchronized orbital relationship with Neptune tend to keep their distance, reaching their closest point to the Sun when Neptune is on the opposite side of its orbit. But 2020 VN40 defies this trend. From a bird's-eye view of the solar system, it appears to approach the Sun at the same time as Neptune. Sounds straightforward, right? Not quite. Here's where things get weird and controversial. While it might look like 2020 VN40 is cozying up to Neptune, appearances can be deceiving. In reality, this object is plunging deep below the solar system's central plane, almost like a stealthy intruder sneaking through the shadows. No other known object with a similar orbital rhythm behaves this way, even when you flatten the solar system into a two-dimensional map. This unusual motion has left scientists scratching their heads and asking big questions. This new motion is akin to discovering a hidden beat in a song we thought we knew inside out, says Ruth Murray Clay from the University of California, Santa Cruz, one of the study's co-authors. It could fundamentally change how we think about the movements of distant objects in the solar system. So, what does this mean for our understanding of space? Simply put, it suggests that when orbits tilt dramatically, they can create patterns of motion that are both surprising and unprecedented. And this is just the tip of the iceberg. The LIDO survey has already identified over 140 distant objects, each offering clues about the solar system's outer reaches. With upcoming telescopes like the Vera C. Rubin Observatory on the horizon, scientists expect to uncover even more cosmic oddities. Each new discovery brings us closer to piecing together the hidden story of our solar system's distant past, one tilted orbit at a time. As Catherine Voke of the Planetary Science Institute aptly puts it, this is just the beginning. We're opening a new window into the solar system's history, revealing secrets that have been locked away for billions of years. But here's the part most people miss: discoveries like 2020 VN40 aren't just about adding another name to the list of celestial objects. They challenge our assumptions and force us to rethink everything we thought we knew about the solar system. Could there be other objects out there with equally bizarre behaviors? Or is 2020 VN40 truly one of a kind? What do you think? Share your thoughts in the comments below and join the conversation. Journal reference: Rosemary E. Pike, Ruth Murray Clay, Catherine Voke, Mike Alexanderson, Mark Kant, Samantha M. Lawler, Ingtung Chen, Arcelia Hermosillo Ruiz, Cameron Seamanchuk, Cameron Collier. LIDO, discovery of a 10-to-1 resonator with a novel libration state. The Planetary Science Journal. DOI 10.3847/PSJ/ed22, https://doi.org/10.3847/PSJ/ed22.